Welcome to Ask and Learn.
Hello everyone. The question we have here is of height versus head circumference dataset. So for the results from problem of height versus head circumference dataset, we have to compute the coefficient of determination capital of R square. So it is a measurement. Coefficient of determination is a measurement which explains how much variability is explained how much of one factor can be caused by its relationship to another factor. It is given by R square is equal to SSE, that is SSE or SSR divided by SST, which is the ratio of the explained variation to the total variation, right, which is equal to n summation over xy minus summation over x into summation over y divided by entire square root over of n summation of x square minus summation over x whole square multiplied by or into n summation over y square minus summation over y whole square. Right. So this is the formula of coefficient of determination R square. So now for this we need to plot a scatter plot in order to get the coefficient of determination R square for the given data set. So for this we use the Excel software in order to obtain the scatter plot for the coefficient of determination R square. So firstly we enter the provided data in the spreadsheet and select insert, and for recommended charts we select the scatter chart and click OK, and from chart area design and chart element we select the trend line options and more options, and we display the equation on the chart and display the small r square or the capital R square value on the chart. So we have a scatter plot from the spreadsheet as follows. So the given scatter plot shows us that the coefficient of variation capital R square is equal to 0.8301, right? So from here we can say that there is not much there is a linear trend in data, but the plot is not much randomly dispersed from one another, not randomly dispersed. Okay, so now for the next part of the question, that is to obtain the residual plot for option B. So residual plot is a standardized for least square regression method. Firstly we should know that it is a standard approach in order to construct the least square regression method is a standard approach in regression analysis in order to approximate the solution of overdetermined systems by minimizing the sum of squares of residuals. It is given by y equals to a plus bx, right, which is equal and summation over y, that is where the variables are y and x and a and b and constant, and summation y equals to na plus b summation over x, and summation over xy equals to a summation over x plus b summation over x square. And the residual plot is, it shows the residuals on the vertical axis and the independent variable on the x-axis. So if points are randomly dispersed, then linear regression is appropriate, otherwise linear regression is not appropriate. So we use the Excel software in order to construct the residual plot, where we enter the provided data in the spreadsheet and select insert for recommended charts and select the scatter chart and click on OK, and from the chart area we select the trend line from more options, and from there we mark the checkbox against the displaying of equation on the chart and display the R square value on the chart. So the scatter plot for the residual obtained is as the least square regression model or residual plot obtained from the spreadsheet is given from the residuals as follows. So from here we can see from the residual plot y, we can say that it follows a linear trend. From there we can say R square is equal to 0.8301 and y is equal to y, that is the least square regression equation, equals to 0.1827x plus 12.493, right? So from here it can be told that the residual plot has been obtained, right? Now for the next part of the question, we have to interpret the coefficient of determination capital R square. So part C is given for the coefficient of determination R square. So since the coefficient of determination R square is equal to 0.8301, so we can say that there is a chance that approximately 83.01 percentage of variation in the head circumference are explained by the least square regression. That is, the credits the explain it, which says that the scores explained by 83.01% variation in the head circumference are explained by the least square regression, right? Now for the next part of the question, that is to comment on the adequacy of the obtained linear plot. So we see the part B of the solution, that the regression in the residual plot, the points are not randomly dispersed here and there, but it follows a trend. So linear trend is not seen. So linear regression is not appropriate for this data set. Thank you. Hello everyone. The question we have here is of height versus head circumference data set. So for the results from problem of height versus head circumference data set, we have to compute the coefficient of determination capital of R square. So it is a measurement. Coefficient of determination is a measurement which explains how much variability is explained, how much of one factor can be